Dear students, this is a PTM 3 physics paper, right? The solid sphere of mass m and radius r has density rho that varies. Actually, this is a bit difficult question, but fine, no issues. Where r less than capital R is the distance from the center of the sphere, the gravitational potential at the center of the sphere is. First of all, let us determine the mass, because fortunately, they are asking this at the center. Right. If it is not at the center, we would have different issues. Let us take the mass part of this entity. So accordingly, we will have, remember, do not take M as a mass here. Here it is a varying density. A density varies from the distance. As the density is varying from the distance in such situations, first we need to find out the mass part. So how to find the mass part? M is given as integral 0 to r. Like you are taking, suppose a shell of radius r and a thickness dr. So this is 4 pi r square dr into rho. Actually, I will call this as some rho naught by r. Right. This will become 4 pi rho naught r square by 2, or simply 2 pi rho naught r square. Let this be equation 1. Now, potential at the center is what you are asking. Every part acts as a shell. If it is a shell, at the center field is gm by r. So this is of mass dm, whose radius is r. I will add all such potentials. Minus g 0 to r dm by r, 4 pi r square dr rho naught by r. So finally this is 4 pi rho naught r. See, in this case, 2 pi rho naught r can be given as m by r. So 4 pi rho naught r, don't forget there is a minus g term also. Minus g 4 pi rho naught r is 2 times m by r. So this is going to be the answer. Bit lengthy one. Second question, 3 particles each of mass capital M are at the vertices of an equilateral triangle. Vertices of an equilateral triangle. Remember, the resultant force is, well, see, please try to understand. This is some distance r, some distance r, some distance r. This is going to be root 3 times gm square by r square. That is the resultant force, because this angle is 60. Each case, the gravitational pull is gm square by r square, and the angle is 60. So the resultant is root 3 gm square by r square. And this supplies the necessary centripetal force. You are asking the time period of revolution. So m and the radius part, you already know. This part will be r by root 3 omega square. This can further be written as omega square is 4 pi square by t square. So this will become t is 2 pi root a cube by 3 g capital M. Very famous question actually. Lot of times we got this question. Particle of mass m is released from rest from the position A. You can see here, position A. And the axis of a fixed ring as well. This is a fixed ring. That is very fortunate. Fixed ring released from here. Very simple. What is the potential at A? Minus G capital M by this distance, R1. Yeah, by the way, R1 is nothing but square of this plus square of this. That will become 9R square, which is nothing but 3R. Minus Gm by 3R. Similarly, at B, the potential is root 4R square, which is nothing but 2R. VA is this. VB is this. Right. So, you apply energy conservation. Total energy at A is equal to total energy at B. So, which is nothing but minus G capital M small m by 3R is equal to minus G capital M small m by 2R plus half M VB square. So, therefore, you will get VB square by 2 as, you bring that over to here, you will get 1 by 6 times G capital M by R, 3 times. VB is G capital M by 3 capital R. G capital M by 3 capital R. That's all. That is correct answer given. Next. Fourth, a very direct question. Kepler's second law is a direct consequence of law of conservation of angular momentum of the planet about the sun. It is a direct question. No deviation at all. Right. Next. Point charges are kept at the vertices of a cube as shown. The potential energy of the system will be how to calculate the energy of the system. Now, count how many positive charges are there. 4 positive charges are there, 4 negative charges are there. If the electrostatic potential energy of the system will be, right. Now, we need to take one of these charges as a reference. Like, for example, you take one of these charge as 1, 2, 3, 4, similarly 5, 6, 7, 8. Now you find the configuration. Now see, one will interact with the 2, one will interact with the 3, one will interact with the 4, one will interact with the 5, or otherwise I'll write like this. Similar situations. See, 1, 4, 1, 2, 1, 5 are alike. 1, 4, 1, 2, 1, 5 are alike. Right. Next, another combinations are 1, 3 and 1, 3 and 1, 8. 1, 3, 1, 8 and 1, 6. These combinations are alike. Right. Now, they 1, 4, all this is a negative actually. And the entire thing is positive. Right. So 1 is done. Now you take with the 2. Don't count 2, 1 again. Now you take 2, 2, 3, 2, 6. Right. 2, 3, 2, 6 are negative again. And apart from this, 2, 5, 2, 5 means this diagonal. 2, 4 is this diagonal. 2, 7 is another diagonal. Right. And last but not the least, Here I forgot to take 1, 7. Here I need to take 2, 8. Right. 2, 5, 2, 5, 2, 4, and 2, 7 are positive. 2, 8 is again negative. 1, 7 is also negative. Right. But I like combination. Likewise, you will get total potential energy as negative. As a negative. Right. Therefore, that is what they are expecting. But of course, it is what you call a different question. Depends on the side length of the cube is also actually to be involved. But I am comfortable with B, so I'll go with B. Right. But I'll come to this later. Sixth question. You have consider electric field given the flux through the shaded area. See, what is a normal drawn to this? Normal drawn to this. The normal drawn to this will be root 2 I cap minus 1 by root 2 j cap. Why? Because you see 0, 1, 1 comma 1, 1 comma 1 comma 1. That is how it is. So therefore, no, it's not k cap actually. A unit vector onto this is like this. So what is area vector? Area vector is 1 by root 2 I cap minus 1 by root 2 j cap, k cap times, here this is all unit vector. So therefore, you need to get answer as 1 meter square. So that is the area. So flux is E bar dot A bar. Simply, E has only I cap component. So 2 into 1 by root 2 into root 2. Cancel, cancel. 2 Newton meter square per coulomb. So correct. Right. Then seventh question. Seventh question, you will have the situation like this. The seventh question situation is like this. You have electric field in a region given by so and so uniform electric field actually. Very simple. You go with the E bar dot R bar. That is the expression for minus E bar dot R bar. Remember, this is allowed only for uniform electric field. So therefore, 3I cap plus 2J cap minus pi k cap dot I cap plus 2J cap plus 3K cap. That is minus 3 minus 4 plus 15. 15 minus 7. This is 8 volt. Correct. Now you have 6 charges of equal magnitude. What you have? See, 6 charges of equal magnitude, 3 positive, 3 negative are to be placed in the corners of the regular hexagon. So the field at the center is double that of what it you have done if only one positive charge is placed at R. Right. Identify the suitable combinations. 1 minute. Suppose if I place a minus charge and a plus charge. 1 minute. A plus charge and a minus charge. Suppose all that the fields need to be towards R. For example, I'm taking like that. This acts like a dipole and this gives a field in this direction. Similarly, I am taking a combination like this. That will also add field like this. Now you take a negative charge and a positive charge. This will also add field in this direction. See, combination is plus minus here gives field in this direction. Plus minus also gives field in this direction. All are in that direction only. So let P, Q, R, S, T, U plus minus 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 plus plus. Now this won't work. The problem is at this point you won't get double. You will get more than double. So this is not the correct option. But field aspects, this is okay. Now I'll do small correction here. Small correction here. Small correction. What if I choose plus minus over here? What happens? You will have field like this. That is fine, but in this case also it won't get double. It is a possible only the PQ is compensated with the TS. Yes, I'll explain. I got a very clear clarity now. Plus minus. Remember, due to this, if the field acts in this direction, due to this combination, the field acts in this direction, cancel. Forget about it. Now you take a negative charge here and a positive charge here. Now you will have field added. Remember, what if there is only negative charge here? Only negative charge here. Field is E. Now what if you have a negative and positive charge here? Field will be 2E. That's the case you want. So therefore, PQRSTU plus minus minus plus minus plus. That's the order. Identify the suitable arrangement. In which direction of minus plus plus minus plus minus. If I go like this, I have one combination like this. Because plus minus, no, this won't work. This is failing. PQRS is what I am following order. Here A is not correct. Let us try B again. B again. Minus plus plus minus 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 plus. If it is PQRS, then I think the nearest possible answer is only C. It is the only possible. This is one case here. Actually, the other possible case is minus plus plus minus. Even in this case also they will cancel. Minus plus. Now you tell me minus plus minus minus. If it is order PQ or S T U, minus plus minus minus plus plus. So that is what I am thinking about. No, in that case, this should be plus and this should be minus. Why I will explain. Because the combination gives a field in this sense, and the combination field gives field. They will cancel, of course. Plus minus also, same situation you will face. So minus plus, plus minus, plus minus, minus. Fine. So what I am getting the answer as minus plus, plus minus, plus minus, minus plus, plus minus, plus minus. C is the possible option. Actually, this is also possible. Plus minus, minus plus, minus plus. But there is no such option that justifies this. Two options are possible. But C satisfies this. So I'm going with that. Next, electric field on the axis of a short dipole at a distance r much greater than the length of the dipole from this dipole is E1 and at a distance 2r on the perpendicular bisector is E2. Right. What do you want? See, E axial part is Kp 2Kp by R cube. E axial, if they are asking, actually they have given E1 bar. Okay. This is in the direction of dipole moment, P bar. So E equatorial is Kp bar by R cube. Kp bar by actually opposite. This is R cube, but at a distance to R. 8R cube. So that's the deal. E2. Then this can be written as ninth question. If I take 2 at a distance R on the axis of a short ball E bar, here this can be written as Kp by R cube can be written as E1 by 2. I am getting the answer as minus K minus E1 bar by 16. Here E1 by E2, if I take, what happens? If I take E1 by E2, only magnitudes 2 by 1 by 8. 16 is to 1. Obviously, minus E1 bar by 16. I think the answer needs to be B for this. Okay. At a distance 2r on the perpendicular bisector is E2. It should be B. Final must be B. They have given D as the answer. I'll work on that again. Right. 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 Next. 10th question. A non-conducting hollow hemisphere of radius r is uniformly charged. Surface of the electric potential at point P. Here, what if there is a full sphere? Same, you will have 1 by 4 pi epsilon naught. Charge by radius. Remember, the entire thing is equipotential. The entire thing is equipotential. Right. So in that case, multiply R by R, you will get what do you call K by 2 pi R square times R by 2 epsilon naught. Remember, this is the sigma term. Sigma R by 2 epsilon naught. Yeah. Right. Question number 10. Remember, the entire plane will, why? Because the electric field lines are perpendicular to this plane. So therefore, the entire plane becomes equipotential. Right. 11th question. Two particles of mass small m and capital M are initially at rest at infinite distance apart. At what instant? At any instant, when their separation is d, square of the relative velocity of approach due to mutual. We do this in C frame of reference. Half mu v relative square minus g capital M small m by d infinitely separated 0. So therefore, in this case, V relative will become 2g capital M small m by mu. Mu means reduced mass. Capital M small m by capital M plus small m. So finally, this should be 12th question, during the motion of a planet around the sun in elliptical orbit, when the planet square of their velocity is what they have asked, right? When the planet comes nearer to sun, its linear speed increases. Yes, I told you very clearly earlier. If this is ellipse, if this is a sun location, here you will have maximum speed, and here you will have the minimum speed. So increases, right? 13th question is, figure shows three concentric spherical shell conductors ABC with radii R, 2R, and 4R respectively. A and C are connected by a conducting wire, and B is uniformly charged. Right. The charges on the conductor A and C are respectively. For example, imagine that I'm just showing a part of this is A, this is B, and this is C. See, here since they are connected, potential of A is same as potential of B. You are given charge only to this Q, and this is Q1, I'm assuming, and this is Q2, for example. Remember, they were connected, right, without touching B. This will become Q1, area K anyway common, Q1 by R plus Q by 2R plus Q3 by 4R is equal to Q1 by 4R plus Q by 4R plus Q3 by 4R. Of course, K common both the sides. Now the question is 3Q1 by 4R is equal to minus a Q by 4R. Q1 minus Q by 3, and that should be plus Q by 3 because net charge must be 0. No? So A is the correct option. 14th question is a simple question. See, at this point, centroidal point, pressure can be given. See, this is at this point, pressure is sigma square by 2 epsilon naught into normal area. You said this is R by 2. I'm taking this as R. Pressure, electrostatic pressure into normal area. So sigma square by 2 epsilon naught times, what is the normal area? It is nothing but under area is what you are asking, pi R square. So sigma square by 2 epsilon naught times pi into R square minus R square by 4 under root. So this will become sigma and square of this. So this will become 3 sigma square pi R square by 8 epsilon naught. Correct. 14th question. 15th question. Positively charged particle with charge Q and mass m is made to circulate around a long uniform linear charge distribution of linear charge density minus lambda, due to which electric field at this point, which is at a distance r, is given by lambda by 2 pi epsilon naught r. Now this is the field and this is the force, and this force supplies the necessary centripetal force mv square by r. So what do you want is speed of the particle. V is root lambda q by 2 pi epsilon naught m, right? A uniformly charged hollow spherical shell of radius 4 centimeter is placed such that the center of the sphere is at the origin. Which of the following is true? Right? Hollow charge, uniformly charged hollow spherical shell, radius 4 centimeters, is placed such that the center of the sphere is the origin. Which of the following is true? See, this is like an arrangement like this. The center is like this. Radius is 4. Right. See, every point inside as well as every point on the surface. If, for example, you select a point, this point lies inside this shell. You take this point, for example, 2 plus 2 plus 2. Radius square is x square plus y square plus z square under root. This is root 8. 2 root 2. See, in fact, this is also less than 4. So, both the points lie within the shell. In case of C, they will be at the same potential. Correct. But whereas this point is inside and this point is outside, they will have different potential. Electric field is non-zero outside the shell. Electric field is non-zero, wrong. It is 0 at 3, 0, 0. So this is wrong. At least if you don't find C on the basis of ABD, you can identify the correct answer. Right? In which of the following cases, potential at center at point O is not 0. Remember, no confusion, not 0. Remember this, how much charge you have here, the same amount of charge here. So in case of 17 at A, see, potential will be 0. 0 here. Plus Q, 2Q minus 3Q. Net charge is 0. So obviously at center potential is 0. Plus Q plus 2Q minus 2Q. Net charge is non-zero. So at O potential is non-zero. Next. Okay, at least I have identified that potential is non-zero here. I need to confirm. Otherwise, also C is my answer. But I'll confirm. Potential at O, Q by R plus 2Q by 2R minus 6Q by 3R. This is again, this is Q by R, 2Q by 2R. This is nothing but 2Q by R minus 2Q by R 0. So potential is 0. So only option available is C right now. Dipole is placed parallel to the electric field. W is the work done in rotating the dipole by 60 degrees. The work done in rotating by 180 degrees from the original orientation is. What is W? Let me identify. W is minus PE cos theta. Actually, you know the formula, rotation, PE times 1 minus cos theta. That is the actual formula. So PE times 1 minus cos 60. Keep it like that. This becomes a PE by 2. W is PE by 2. Here rotating 180 from the original direction. This will become 2PE in that case, W dash, which is nothing but 4W. So correct. Geostationary satellite is revolving at a height 5r from the Earth's surface, where r is the radius of the Earth. The time period of the satellite, which is at a height of r from the Earth's surface, RAR T square proportional to r cube. 24 square by T square is, you said height 5r, so 6r. You said height r, 2r whole cube. So this is a 3 cube. So T is 24 by 3 root 3. This will become 8 by root 3 hours. 20. Suppose a tunnel is made in Earth which passes through its center. If an object is dropped from height r by 2, if an object is dropped from height r by 2 from the Earth's surface above the tunnel, what would be its speed at a depth r by 2 from the center, from Earth's surface in the tunnel? See, only thing that you need to know is potentials actually. See, at that height, potential is simply minus G capital M height R by 2. So 3R by 2. Potential inside depth point is, you already know this, G capital M by 2R cube times 3 capital R square minus a small r square, minus G capital M by 2R cube times 3 capital R square minus small r square. Small r means r square by 4, minus G 12 minus 1, 11, 11 Gm by 8R. That is the potential at that depth, right? So what is that we need to do is Gm small m by 3R by 2 is the total energy initially. Total energy finally is Gm by 8R plus kinetic energy. By solving which, you will get C as the answer. Next, a planet is revolving around the sun in an elliptical orbit. The speed of the planet as shown P, as shown P is, find the value of X. Remember, you want to find the speed at this point. And now this speed is R. R is nothing but B square plus, and you know this is AE actually. A square, E square. But you know R is nothing but A. R is nothing but A as per the ellipse geometry. B square plus A square, E square. And one more important point is, okay, one minute. This is fine. I know already R. I don't require all this stuff actually. You want this at point P. Speed of the planet at this point is what you want. What are the energies there? G capital M small m by R means A actually, plus half mv square. That is the total energy. I told already earlier, the total energy in an elliptical orbit is 2A. This already, you know, A, geometry of the ellipse. So this gives, half mv square is minus G capital M small m by 2A plus G capital M small m by A. M. V square is minus G capital M by A plus 2G capital M by A. Finally, V is right. So obviously, in the place of X, you should get 1. Two isolated metallic solid spheres of radii R and 2R are charged such that both of these have same surface charge density sigma. The spheres are located far away from each other and are connected by a thin conducting wire. Finally, they will get the same potential. So you know what they have given? Initially, Q1 is sigma times 4 pi r square. Q2 is sigma times 4 pi 4r square. That is Q1 plus Q2. So total charge is constant. I can write this as 5 times sigma 4 pi r square. Right. right? Q. So when they were connected, potentials are same. So what I mean to say is Q1 by R is the same as total charge. 5 sigma 4 pi R square is the total charge minus Q1 by 2R. Finally, potentials are same. So this gives Q1 is 5 by 3 times sigma 4 pi R square. Okay, this is the charge on the first one. What they want is a charge on the bigger one. So what about 5 by, you take this as some x, 5x minus 5 by 3x. So this will become, you want the other part of the charge, right? Good. So you want this charge actually. So 5 times sigma 4 pi r square minus 5 by 3 sigma 4 pi r square. And remember, this is 15 minus 5, 10 by 3 times sigma 4 pi r. That is the charge on the bigger one. Charge on the bigger one. New charge density is what you want. This is the charge. So new charge density is 4 pi 4 r square. This will become 10 by 3 sigma 4 pi r square divided by 4 pi 4 r square. 4 pi 4 pi cancel. R square cancel. 10 by 12. 5 by 6. It should be 5 by 6, 11. Right. Work done in assembling the charge Q uniformly and a shell of radius. They are asking a cell formation energy. This is kq square by 2r, or 1 by 8 pi epsilon naught times q square by r. In the place of n, you have 8, and that is correct. Potential difference between two concentric uniformly charged spheres is V. If the charge on the outer sphere is doubled, then the new potential difference will be, remember, see, when you have two such spheres, R1, say R2, the potential difference strictly depends on K by Q, the charge on the inner sphere, Q1, say Q2, Q1 by 4 pi epsilon naught times 1 by R1 minus 1 by R2, independent of the charge on the outer sphere. So even you double the charge on the outer sphere, it is still the same V. Answer is 1. Correct. Next. The weight of a body is the same at a height h above the surface of the earth and at a depth h below the earth. Hold on. It's like gh is gr square by r minus h, r plus h whole square, which is the same as g times 1 minus h by r. D by r actually h by r. Right. So r by r plus h is equal to under root 1 minus h by r. Now you need to, so 1 is root 1 minus h by r times 1 plus h by r. Just solve this, do squaring on both the sides. 1 is equal to 1 minus h by r into 1 plus h by r whole square. Take h by r as some x, some p, you'll get whatever you want in that. Calculation is the criteria there. Calculation part plays the major role. Right. So that's all, 25 questions. It took 44 minutes for me to discuss this paper. Right. See, I am telling you again, this is the only difficult one. Fifth question is bit difficult one. Maybe for you, eighth is also a difficult one. Eighth question is also a difficult one. And maybe 10th one also a difficult one for you. So this would hurt you. Otherwise, the rest everything is fine for me. Mostly, most of the questions are discussed models. They were not new for you. They were not at all new for you. So therefore, I think it is a good paper. You can make it, right? That's all.